All right, so we're gonna talk about Flowchart and Pseudocode CSC 200. Well, we'll come back here. So make sure you stay focused. All right. So what's Flowchart? What's Pseudocode? So first, you need to understand what is algorithm.
What is what?
Algorithm. Like
a pattern or a code or something?
It's a calculation.
okay, so someone said calculation, someone said pattern of code, someone said rules. We talk about algorithm, right? So let me pull up a slide. I mean, the algorithm itself. Let's see what this slide defines. Okay. We said there's a problem, right? That we try to solve. And we try to use an application like software to help solving the problem. We want to convert a real world problem into something that we can compute because that's machine, right? So in order to do that, we need to develop an algorithms and use it to solve the computational problem. Now, an algorithm is a precise list of instructions that determine what operations to perform on what pieces of data in what order. Okay, that's can be one definition of algorithm. So list of instructions, right, with the order, like what to do with the data, right? So let's see an example of computing sum of two numbers. All right, so I'm sure everyone know how to sum. Raise your hand if you don't. Okay. So the problem is try to give me the sum. How would you give me the sum? Can you list out the instructions or create the algorithms, right? So let's go back. An algorithm is a list of instructions. So can you list out instructions, anyone? Think about. Okay, take a number.
Scanner.
And take another number.
And then add them.
And add them.
And then display the answer.
Okay, so let's see. I'm going to do that together now. So I'm going to write down the instructions. You said first, you said take a number, take another number, add the numbers. What else?
And then display the answer.
Display the answer. All right. Can we make this better than, like?
Yeah, we can.
Should you say
Take
like
an integer.
input a number?
No, an
Input
int.
another number.
Okay, input. So yeah,
Well, it
let's
depends
say
on
any
what
numbers.
you're
We
doing.
want to sum any numbers. Doesn't have to be integers, like real numbers. Input a number, right? Input. Okay, a number. Okay.
A value.
Or you want to say input first number,
Okay.
and then instead of take, we want to use a keyword, but input second number, and then
Sum the numbers.
like you see you want to display the sum. So if you want to display the sum, then you should say
Add the first number.
calculate or add. That's fine. Add or calculate, right? Or
Add the first and the second number.
yeah. Or if you want to say sum equals to first number plus second number, we just want to define it a little bit more computation, right? From the real world problem. And then yeah, lastly you can say display or print or show, which is fine here, right? So let's put in caps. So this are actually the keywords. All the caps here are the keywords for pseudocode. And this is pseudocode. Pretty much just a set of instructions. Okay? We just call it pseudocode, right? Alright. So now we understand what is algorithms, and we see example. Yeah, this one just show you read input, read second input, add just like what we just said, and display, right? And now we just turn that into a computer is a machine that can compute. That means can represent, manipulate, and manipulate data. So programming is about finding a way to tell the machine what computational operation it must do on what data. Program is just an algorithm. It's just another algorithm that expressed in a computer language that computer can understand. That's what we did, right? That's the algorithms that we did on the notepad earlier.
So programming is kind of like an algorithm?
Yeah. But it's just, remember when you write program, you actually write an algorithm. But you just need to follow the syntax that the machine can understand. So now when you design a program, right? Like when I asked you to find previous assignment to find the width, to find rectangle, right? Parameters and area, right? So how do? You pretty much just implement it right away. Meaning that you open the editors, you type in the code, right? But in reality, it's actually have to break into two phases. Like the first one is called problem solving phase, which is an algorithm, which is the phase just like the one that we seen on the notepad earlier, right? That we list out all the algorithm first. And then the second phase pretty much as you start to do coding, or we call implementation. Like you start to open your notepad, VI or IntelliJ, and start to type your code, which it could be translate the algorithms that you just list out earlier into any computer languages. It doesn't have to be Java. We just pick a Java as a language to communicate to computer. Communicate what your algorithms. And why we want to do that? To solve the problems of the algorithms. Which is the problem now is just find the sum. Questions?
Yeah, so like the people, like even like CSC 202 and stuff, when you like give them assignments for a code, do they normally like write it out first, like on a piece of paper, sort of like the steps, and then code it, or like?
No.
Because I would think if the code gets like when it starts getting really complicated, you want to like write it out first.
Right.
Not like the code exactly, but.
When the code getting, if it's hello world, pretty much you already know.
Yeah, not like that.
Some you already know, but when it get complicated, like complex problem, like you try to build a house, can you just go out and buy the bricks and mortar and build a house? You just want to make the design, which is the design phase, right? Technically, you could build a room, right, without a design, but it may come out not right. Maybe the window is too small or the door is too big. That's why we want to design first, right? And when we handle the complicated or complex problem, the design is very important now, right? Because let's think about when you just solve the problem for math, you still need scratch papers and pencil, right? If you have a simple problem, then it's fine. You don't need to write it down. But when it starts to be complicated, that's why we need to design first.
Professor, so basically, your code is the algorithm?
Yes. You try to write in the computer language.
Yeah, so you put the algorithm in the computer language and that tells the computer what to do.
Right. So we talk about pseudocode here. It's just a generic way, like a common way that people look at. That's why we want to use a common keywords like input, right, instead of take, right? So input, that makes more sense, right? So you don't have to worry about a programming language at all. Like input, first number, that's not a computer language, right? So, and it helps programmers to plan and algorithms. And sometimes they borrow some syntax from programming language to use in pseudocode. And you can have different styles. There's no like solid, say, hey, it has to be this format. No. So let's look at another example. You want to calculate the bill when someone buys a specific number of some item. So we gotta write pseudocode. How we do that? Sometimes it's gonna be hard to start out, right? So the easy thing that you want to do is ask what you don't know and what you already know. So first, known, do you know anything about this application? Calculate the bills when someone buys a specific number of some items. You don't know everything. So do you want to ask the user then? Then you have to start by prompt, right, for number of items being purchased, right? So because in order to calculate, you need the user to provide those unknown information, right? So we going to prompt the user. So after you prompt, what do you want to do? You got to have to read number of items being purchased, right? Because this is a computer, right? There are two steps. You prompt, you read in, right? And then you prompt for price per item, because we don't even know the price per item. How are we going to calculate the bills? And then you're going to read price per item. Now we have enough information, right? So we just do calculate, right? Subtotal, which is you're going to multiply the price to the number of items. And then you get a subtotal. And then we want to calculate for the tax. And then we're going to display, right? Calculate for the total first. And then display the total. So that's pretty much just another example of writing pseudocode, right? So now you start to see that we use pseudocode, then we want to have a common keywords, right? Like when you try to get input, so those are input, read, or get. When you try to display or output, print, display, show, or prompt. When you try to calculate, we call compute, calculate, or determine. When you want to initialize the values, we call set or init. When you want to add one, you just do increment or bump. When you get to decisions like if else, then we have to do if, then, and else. Test. And we're going to cover about loops, which is while do. We're going to talk about that. So when you write an algorithms, you have to be certain that the tag is completely specified. Like I just said, you have to ask the question again before you write an application. You understand the question and you want to say what data is already known. And another question is what data must be input by the user. Like for example, the previous example, we don't know anything, so we want to ask users to provide number of items, right? And the price per item. But if we already know the price per item, then you don't have to ask the user. So that's going to be a known, right? And then you want to ask yourself what computations will be performed on the data. Like we find the subtotal and we find the tax. Those are two computations, right? What data will be output to the users? So they want the total, or they want subtotal, or they want subtotal, tax, and total. So those are the things that you can also ask when there's a question about ask you to write an application for showing the bill. Then you can always ask the customer or the one who asked you to do that. What I already known, what are the inputs from the users, what type of computation I need to do, including taxes or not, right? And what are the information that I need to display. So those are requirements. Then you can start to design the program, right? So let's say another real world problem. We want to calculate the allowances for 2 trillions based upon 75 cents per year old. Alright, so we want to write a pseudocode, right? And algorithms with pseudocode. So how would you do that? What you already known, right? What you already known first. So you know the rates, right? Rates equal to 75 cents per year.
Number of children.
You know the number of children, that's correct too. Okay. Now we're going to use that if we want to use the loop. But now we're not going to worry about that yet. We're going to prompt the user 2 times, right, to ask for the ages of input because those are unknown, right? We need to prompt the users for that. Alright, so once we know that, are those information enough to calculate? Yes, because age times rates, right? Age times rates, so we get the allowance for each children. And then we get going to be output allowances for each child, right? And this is how we write out the pseudocode after we answer all those 4 questions. So we prompt for age of child 1, read age of child 1, same thing for child 2, and then we calculate, right, by say allowance for child 1 equals to age of child 1 times rate. Same thing for allowance for child 2. And then we display allowance for child 1 and child 2. That makes sense? So when you train yourself to design the code first, it's going to make you more systematic, right? Be able to solve the problem easier. Sequential program statements. So now let's talk about this. So when we write a program, we have to do step 1, step 2, step 3, right? Like we have to set the rates. We have to ask the user for age. You cannot display output before those 2. And then you have to calculate. You cannot calculate before you get it. Age. See that? So that's a sequence, right? Something has to come before, right? And then you can display. So this are called sequential program statements. You have to execute one statement after another, right? So every step in the list will be performed. Each step in the list will be performed once and only once. So this is called sequential, like the list, right, that we've seen. Non-sequential, right? So you see that if we look at sequential program, it's kind of pretty simplistic. And most programs need more flexibility in the order of statement execution. And the order of statement execution is called the flow of control. Control statements allow the execution of statements based upon decisions. Alright, so we're going to talk about decision. We talk about an example of if else now, right? Because it's no longer sequential, right? So it's based on the decisions to perform the task. So the control statements or flow of control is depending on the conditional statements, right? Because it has to decide whether or not to execute a particular statement or another statement, right? This one we call like selection statements or decision statements. So let's look at an example. Like if I want to calculate the pay for the hours, if you're working over 40 hours, it's going to be overtime pay, right? So in this case, it's no longer sequential, right? So we have to make decisions by using if hours work over 40, then you display overtime pay, else you display regular pay, right? This is a decision. The questions?
Oh yeah, so like all the codes we've read so far and stuff, like even if they're not sequential, like even with the if then and else, like the if else statements and stuff, is it possible to like write a code where like say instead of just having like a JavaFX dialog box appear at one time, like two appear at the same exact time, like where two things are happening simultaneously instead of at different time points? Did I say that?
Yeah, you can. I mean, with the speed of the machine, you could do that, but in reality, it still have to pop up one dialog before the other one. But human cannot tell the difference because the machine
like
speed very fast.
0.0000001 second after the other. But
Depends on your CPU, because maybe your CPU is freezing at that time because of viruses. But also depending on the CPU speed and many constraints. But you can see we cannot tell different because machine just doing so fast. All right, so let's look at another example that we want to show you how to use a pseudocode for the selection statement. So we modify the same example a little bit. We said we're going to calculate the child's allowance based upon 75 cents per year old if he or she is under 10, and $1 per year old if 10 or over. All right, how would you write a pseudocode for that? Okay, let's construct that together.
Yeah, why?
Rate equals 75 cents if lesser than.
Doesn't feel like a need.
So we start to define the known, right? And the known one we said 75 cents for young rates,
Yeah.
100 cents for old age, right? Or old rate. And we said we're gonna have the break age
What's the
at 10, right? The cutting point, right? All right, what's next? Are those all the known values so far?
Yeah.
All right, so now if it's yes, then we need to ask the user for the age, right? then we're going to input age of the child, correct?
Wait. Yeah, no. Okay.
Alright, so after we get input of the child, do we need anything else? This is for one child, so that's enough. We start to calculate. Now, how will you calculate? Same thing, allowances equals to age time rates, right? And then we output allowances, right? But this is just to answer to 4 questions, right? Now we start to write the pseudocode, right? Alright, how will you write the pseudocode?
If age equals
The user for age.
Prompt for age. What's next?
Read the age.
Read for age.
display
You have to write the if else statement.
At this point, you have to make decision because it's not sequential. You have to say in
If the age.
if the age less than 10, right? If the age less than 10, then you calculate what? Allowance equals to age times young rate. Else, you calculate allowance equal to age times older rate. And then display allowance. That's simple. Okay? Now, we've seen the selection statements. This is called loop statements. So what's loop? Repeating, repetition over and over again. Like, example, we come to class every Tuesday and Thursday at 4 o'clock. So we're gonna repeat doing this where it's Tuesday at 4 o'clock and Thursday at 4 o'clock. We have to be here, right? Now, when you do repeating, you have to have the pretty much just the cutting point, right? When to stop, right? So pretty much we said we're here for 16 weeks, right? Of class. So 16 pretty much is the condition. While you start to initialize your count, attendance, your tally start 1, 2, 3, right? You keep increasing by 1 whenever you come, right? So while less than 16 weeks, so you're gonna do. Now when it start to be 17, then you no longer come. So that's how you stop the loop. Yeah, the looping. So that means if the program happen to get into the loop, it's just gonna do that. It's not gonna do another statement, right?
Yeah.
It's gonna keep whatever inside the loop. The statement inside the loop is gonna keep doing that, right? So it's repeatedly execute the same statement for a certain number of times, or until a test condition is satisfied. In this case, our satisfied is 16 weeks, right? So it depends on situation. So that's one example. Now let's look at pseudocode for that. The pseudocode for the loop, we normally use the word while under the limit do, right? Like while week count under 16 do, right? Do come to class, if you want to say that, right? Or this one is example of population under limit do computed populations, right? That's just an example how to write the pseudocode for loop statements. Now let's look at another example with the allowances again. So now we want to calculate for how many child? 3 children instead of 2. So meaning that when I prompt and read and calculate and display, I could just make a loop for that. Because so in this case we can just do the loop then. How will you write the loop for that? So first question before you write pseudocode, pretty much is what are the known values? 3 students and the rates, right? $1 per year, right? So inputs, we already known everything. What are the inputs? Age of the children, right? Ages of the children. Calculation, we already know allowance equals to age times rate, and then We want to output total allowance paid, right? So now we understand the problem. So start to decide the pseudocode for that with the while, right? Pseudocode statement. So we're gonna start to write. Anyone want to start out?
The user
Hmm?
get age.
If you do that, it's not gonna be able to use with a loop,
So while something.
right? But we want to initialize the values of the cutting point or initialize the value of the count.
So
Like we want to set kids, the number of kids that we just call the number of kids or the count of how many kids we calculate. We call kids paid. Remember, we have to keep tracking like how many weeks we come. Start from week equal to 0, right? So this is starting how many kids we calculated. Kids paid to 0. And then we have to set the total. Because they want to find a total of 3 kids, right? You only display the total. You don't have to do each kid, right? So the total, we set the total to 0 too. And then we're going to accumulating it. So now we want to do while, right? While kids paid under 3, under the limit, right? We do. What do we do? Now we start to prompt for the age, right? Start to read for the age, right? If you do prompt before, then it's not in the loop. Then it's not going to do repeating prompt again and again, right? And read again and again. Because these are repeating statements, so it has to be inside the loop statement, which is while, right?
that sets like
And then same thing, calculate too, right? It's repeating.
kid, then you can put in like
And now you want to find the total. You're accumulating it. Add allowance to a total every time in the loop too.
whatever else you need to put in there.
And then we're done. We just gonna be. Oh, before we do that, remember we have to do tally to increment the count every time. If you never increment kids paid, then it will loop forever, right? Because start kids paid to 0. Say we start from 0, 1, 2 is dated twice. I mean 3 times now, right? And then we done. We just display the total. Any questions? So it's a little bit new for you, so you just need to maybe go back and review it. Okay.
Are you gonna post the PowerPoint on Blackboard?
It's already on Blackboard under course documents.
The professor said they like students to handle their own problems.
So we understand pseudocode, we done. The next topic is flowchart. So what's flowchart? It's just an alternate of pseudocode. You can either write your algorithms on pseudocode or flowchart. A flowchart is pretty much a graphical way of writing algorithms. So you're going to use a symbol like rectangle. But you need to know that the symbol means calculations if the shape is rectangle. But if the shape is parallelogram, it's going to mean input or output. If the shape is circle, that's used for connecting. If the shape is diamond, that's making decision like if else or while, under, limit. And we use the arrows, right, to connect between those symbols. Okay? Calculations. Let's see example of rectangle for calculations. Like we may have input earlier, right? But the part of calculation we put in rectangle, like total equal to cost plus tax. Example. How you use the flowchart for that. Like this is another one when we want to increment by 1. Like when you do count in the loop, right? We just do num equals to num plus 1. Now another example for input and output, we use the symbols called parallelograms. So this is for read num, right? Output just display num or write num. So for you, when you do prompt, technically it's like a display or write, right? Another example on how to use decisions, we use the diamond shape. So based on the condition being true or false, the next operation will be determined. Like this is an if else. So let's say if the gross greater than 50,000 is true, then we use the rate 0.31, right, to calculate for taxes. False, just like else, we use the rate 0.28 to calculate for taxes. And then we connect back to the sequence of the program again. Use the oval or circle to be the joining point of connections.
This is like a visual way of showing the algorithm?
Yes.
Okay. So this is like, so you can see it's not just like words, it's got everything. So you see how it works. You got that?
So decision is composed of a condition. You can see there's a condition inside here. And operation to be done if condition is true. Right. And another operations to be done if the condition is false. And also we used, when you start the, pretty much start the algorithms or start the flowchart, we're going to use an oval to represent start, and also another oval to represent stop. So you combine them all together, right? Start, input a number. This is pretty much just find a square, like of rectangle that we learned last time. This is flowchart for that. Square equals to nums times nums, and print the square and then stop. So that's complete flowchart.
Now, if we're gonna have to write like an algorithm, would you want a flowchart next to it just so it can be like a little more visual, or can we do either way?
For your 3.3, you're gonna do both.
Okay, alright.
Okay. So this is pretty much his question. He said, I have the pseudocode. This is an example of pseudocode for calculating the allowances for 2 children. Right, we prompt for age of child 1 and read and prompt for age of child 2. And we calculate same thing. When you look at flowchart has to start prompt age 1, input age 1, right? Just like that. Read and prompt.
If you didn't put the stop, would it be on a loop?
I think the sequence here is wrong. You have to prompt first before you read, right? The typing here is wrong on the left. It has to be prompt before you read. Because you cannot read before you prompt, right? Alright, so we prompt, we read, and you see that in flowchart, you pretty much just has to do use what parallelogram for that, right? Prompt and read. And then we do calculate, we use rectangle for allowance 1 and allowance 2. And then we print again, so we just do parallelograms again for allowance 1 and allowance 2, and then we stop. So that's how you do pseudocode and flowchart together. Question?
Yeah, well, so, you know the stop? If you take that stop out, will it be on a loop?
Oh no, the stop is pretty much just terminating the program.
Oh, okay.
Like end, start, beginning of the program. Like just like you open your curly braces and closing curly braces for Java code. So let's look at the selection algorithms again compared to the flowchart. Right, so we understand this already, right? We have to do if, but flowchart pretty much just you put a diamond and this is the condition, age less than 10. When it's true, you just calculate in the rectangle allowance 1. When it's false, you calculate for allowance for the older age, right? And then we join back to print because both of them were done, they're going to print. And then stop. Now let's look at another one for the loop, right? So it's pretty much the same thing. We just make decision first. So we initialize pretty much just set, right, the values of the counters kit page to 0. That's pretty much just a rectangle when you do that, right? Because calculation assigning the values. So we use another rectangle to assign total to 0. Now, when we get to the flow, we get to the decision now. Kit pairs less than 3, pretty much just under 3, then it's true, right? While this is going to be while true. You're going to keep prompt the age, read the age, calculate the elements, add to the total, and then increment kit space, go back. Now kit space is going to be 1 because it was 0, right? Then you perform this task again, increment, now kit space is 2. Then you perform this task for the third time for the 3 kits. Kit space 3. 3 is no longer less than 3, it's false. So we exit and display the total. So we exit the loop and then we stop. Okay? So that's how you write a pseudocode and flowchart for the looping algorithm. Alright, so now high level design tool. So we look at that in the low level, pretty much get into like coding algorithms level details, right? Now in the high level, like when you design the system, then you just look at the whole picture. Like if I want to design a car, I just say car, body of the car, engine of the car, brakes system. That's make a car, right? Because run, stop, right? But if you want to get into low level details, then you actually break down how engine works.
So wait, low level is like the simple one? No, low level is the more like detailed one,
right?
And high level is just like the
overall, right?
Okay.
So a flowchart we can be used for that too, right? Like to detail exact how your program will do each task. We use it, we call structure charts, right? It's only showing what tasks your program will do, not how it will complete them. Make sense? So structure chart is or are the hierarchical diagrams based on the hierarchy, right? Diagram overall program structures show the relationship between the tasks in the program, indicate which data is shared by the task. So a large program design is first broken into tasks. like when we want to design a big system, we have to identify all the tags. So tags are repeatedly divided into even smaller subtags. Rectangles are used to represent tags, subtags within the program. And lines are used to hierarchically connect the tags and subtags. Subtags are diagrammed like that. Like we used the line to connect the subtags. This is like a hierarchy. So let's see how we create a structure chart. So now we understand that we have tags that composes of two subtags. We use the arrows, right, to show the directions that the data is coming from and going to. So like this one show an upward arrow indicates that the data value has been set inside the tags and being passed out for use by other tags. And the downward arrow indicates a data value previously set in some other task is now being passed into this task. So data may be passed both into a task downward arrow and upward arrow. Like let's say, example, given a generic program that reads some data from the user, runs some calculations using that data, and display result to the users. So the structure chart should look like this. Like this is the program we call main. And in main we separate into three subtags. First tag is get the input. So we have the data flow. And then we process that data from the user input. And then we get the result. This is just like your rectangle, right? Get input could be width and height, right? And length of the rectangle. We pass the width and length and we process by multiplication. And it's return the result out. And then another tag just display the result. Pass the result to display. Questions?
Is there a certain way that you have to set up the graph, or can you do it anyway as long as it's showing that? Like, is it
I mean, this is just a rule. Just try to show you how flowchart being used. This is called flowchart, right? This topic. So we
you
just
can
only
set up
show
flowchart
you.
in any like way you want as long as it works, right?
I mean,
Or is that
how
the
could you
most
display
simple
this differently? How would you show this differently?
one? So like, if you put the main here and you made it come out sideways.
No, because this is hierarchy, right? That means you have to have subtext under the main task.
No, yeah. So we'll have the main task right here, and we can have this one coming out here.
But that's not the hierarchy level.
Oh.
Hierarchy, that means you have the top and the bottom.
Oh, okay.
Okay, so how could you change this different way? I don't see it.
Well, so basically what I was thinking is if we put the main on.
It has to be on the top because subtext always go under the main and use the line to connect them. And we have three subtags: get input, process data, and display result. Unless you want to make get input to the right, which is not in order.
Okay.
The sequence should be from left to right,
Oh, okay.
right? So let's look at how we're going to make a structure chart for this question. It's pretty much the same questions. The calculates your two children allowances based upon 75 cents per year old. The structure chart might look like: first we have the main, get the ages. Now the data is H1, H2 being passed, and then calculate allowances. H1, H2 pass into this task and returns allowance 1 and 2, and then the task to display allowances pass allowance 1 and 2 in. And that's pretty much how you do the structure chart, right, for the system. But we don't care about how you do the get ages, how you do calculate allowances, how you do the display allowances, right, in details. That will be displayed in the previous pseudocode, right, or flowchart. So let's look at using the structure chart again to calculate one child's allowance based upon 75 cents per year old if he or she under 10 and $1 per year old if 10 or over. So the structure chart should just look like the same: main, get the age, calculate allowance, and display allowance. But the data that being passed is 1 now. So each of the modules in the chart would be called by main twice. If we want to do with 2 children, correct? So the 2 children allowances is still the same. Now how about the looping program? Calculate the total allowance paid to each of 3 children at $1 per year old. So what should the structure chart look like? So we're gonna have the main. So what are the subs? Calculate the allowance total and display total. But to calculate the allowance total, we have another 2 subtags because it's no longer under main, because this one has to be inside the part of the calculations. So that's why we get the age and calculate allowances under the subtext of calculate allowances total, right? By passing the age into the calculate allowance, return allowance to calculate allowance total, get a total to display. The get age and calculate allowance modules would be called every time the program loops, right there, because that's part of the calculate allowance total. The loop's doing here, but you don't need to display into details, right? And I think that's pretty much it. So the summary: when you create the structure chart, put the name of the program in rectangle, root of an upside down tree. You have to determine the main subtask that must be performed by the program to solve the problem, and put main subtask in rectangle below the root. Like in this case, our root is main, right? And draw a connecting line from the root to each subtask. So now you're going to examine each subtask individually and break them down into even smaller tasks. And then if you have more smaller tasks, then you just do another subtask, right? Put subtasks in rectangles below the tasks that they are part of and draw a connecting line from task to subtask. And that's pretty much how you use pseudocode and flowchart. Now, any questions?
Okay, so basically what we're gonna need to do is put it into writing for you first for 3.3.
So in 3.3, you have to write a flowchart and pseudocode. Okay.
And then we gotta compile it in the
So to write flowchart, you can use the tools. Write pseudocode, you pretty much just use any text editors, right? So we have one suggestion is the Lucidchart. You can sign up for free account. Like once you get a free account, you can see that you can create the
That's crazy.
flowchart. These are the diagrams. This is pretty much just like
Okay.
our engineering blueprints here when you design a system.
Oh, that's it. This one. Arlington across ER2. No, yeah, that one. Why isn't the
Now let's talk about something that related.
Oh, okay. See, that's what I was saying. I was like, could we make the chart like that? But you said the main.
So this is a flowchart example. Like, now let's read the question. You want to write a program. After you design flowchart and pseudocode, you're going to write an application with Java code by translating your algorithms into the code implementation phase, right? The first phase, design with pseudocode and flowchart. So you're going to write this authentication program, right, by what's a known? You don't know anything, or you do know everything. What's the known values?
Username and password.
Okay, username and password. Pretty much the system should know the correct username and password, right? And what's unknown? The username and password that the user tried to input, right? And what do you want to display? Or what do you want to compute?
If the input matches with the
You want to compute if it's equals the username that the system known and password that the system known equals to the username and password that the user tried to provide. So that's a computation, correct? So what is the display?
welcome username or wrong username.
Right, when it's true we say welcome. Else we say wrong username and password. So that's pretty much we understand. We answer all the questions, right? 4 questions. Then we can start to write what? Pseudocode.
Do we just write the pseudocode and the flowchart?
We have to do both, right? Requirements, write pseudocode, write
We're not
flowchart.
supposed to do the code like public classes.
After that, you have to do write Java program with VI, right? So we gotta do just like your 3.2 on the terminal and everything, and then you have to submit to the git bash command that you get the trophy from git real, right? You have to understand and do that again. You're gonna keep doing this. First time was difficult, but we're gonna start doing just use git the rest of the class and VI. You're gonna be professional at that time. Because we still have 10 more assignments to go. We have to practice repeating, doing the same thing over and over. It's just like CMD now, right? Make sense? And then don't forget to put a comment for JavaDoc and generate the JavaDoc for that. We talked about that, right? And this is an example of that flowchart that we just talked about. We start. So for the known value, we just put initialize the values to the variable, say the correct username, correct password. So to initialize in flowchart, we use this what's this shape? Hexagon, right? We use that hexagon shape. And now program for prompt username, read username, see that? Prompt password, read password. And now we make decision. This is a computing part, right? Correct username equal to username and correct password equals to password. Then if it's true, welcome username message. If it's false or no, wrong username, right? NAME, wrong username or password going to be displayed instead, right? Because the rectangle, the parallelogram do the display. And then they join back to say finish, which the better way to draw a join should be using what? An oval, right? Connector. And now you can start to draw. So if you just use this tool, it's just make your life easier and simpler. Because if you use Word, yeah, they have the flowchart for you too, but it may take you longer time to draw.
I like how the arrow kind of like moves in the direction you kind of, it goes like, I don't know.
Alright, so that's the flowchart. That's pretty much what you need to do for that, and you have to write the pseudocode with all the keywords that we learned. And this pretty much you use the pseudocode for selection statement. If, right? If what username and password are equals, right? Instead of under limit, right? Now we just use equal statement instead, right? To make it true or false. So the expression itself pretty much just a boolean value, just return true or false when you set that up, a conditions. If we don't have any questions, so we're going to call this a day, and I'll see you guys